All right, so these are the solutions to the group work. So we have this problem, and it is about a taxi company, and you're taking a ride from the airport in Las Vegas that has a charge of $5.10 just to get into the car, and then on top of that, they charge $2.60 per mile, and they ask you to use that information to, one, complete the chart, and two, plot the points to create a graph. So a couple of things. So I noticed that the pattern was increasing by $2.60 every single time for the each additional mile was driven. So if you look, $5.10. If you add $2.60, it gives you $7.70 plus $2.60 gives you $10.30. So to get these numbers that I put here, I just added $2.60 every single time. Now, when you make your graph, I just plotted the points. So I said, okay, at a distance of 0, it was about $5.10. At 1, it was $7.70. These are just approximate points. If they are not perfect, that's okay, because we don't know exactly where $5.10 is. It is somewhere close to the middle, just above the middle. The one thing that I do want to stress is make sure that you do have your arrow, because the distance could go on forever. We don't know when this cab is starting. So that's the one thing that's important. What do you notice about the pattern of the line that you're making? It is a line. Lines go on forever. The distance never ends, so that's why it's important that you put the arrow on the end. Okay, now question number 3 is important. It says the point where the graph crosses the y-axis is called a y-intercept. This is the point where the graph crosses the x-axis is called an x-intercept. So if you look here, this point right where my arrow is, 0 miles is $5.10. That's my y-intercept. We write it like this, 0, $5.10. Okay, x is 0, y is $5.10. How do you always find that point? It's always going to be wherever the line crosses the y-axis. In most cases, it's going to be the starting point, but not always. Okay, and what does that point mean? $5.10 is the fare just to start the cab ride. That's your initial fee. Okay, typically the y-intercept will always be your initial fee. Then it also asks you what the x-intercept is. If you look, there is no x-intercept in this graph. This line will never ever cross this x-axis. It's going to cross somewhere over here. So if you were to take this line and extend it all the way down, it would cross down here. But it's not relevant in this because you can't travel a negative distance. So this particular one has no x-intercept, but what it would be the point where the cab costs absolutely nothing. So when the cab costs $0, but the cab will never cost $0 because you have to pay something to get in it. So that's why this one doesn't have an x-intercept. Okay, so moving on to the next page. Number 4, how much more will you pay for a 3-mile ride than for a 2-mile ride? Okay, I'm taking these numbers right from the chart. So $12.90 minus $10.30. Those are the two numbers that I took right from the chart, from the 3-mile ride to 2-mile ride, and when you subtract, you get $2.60. How much will you pay for a 5-mile ride than a 2-mile ride? So how much more will you pay for a 5-mile ride than a 2-mile ride? Explain why it makes sense based on question 4. Okay, so 5-mile ride, $18.10 minus $10.30 is equal to $7.80. Okay, the 5-mile ride cost, 2-mile ride cost. So the answer from question 4, $2.60, means that you pay $2.60 per mile. If you multiply $2.60 times 3, then you get $7.80. That's the extra 3 miles, right? Because to go on a 5-mile ride or a 2-mile ride, no matter what, you have to pay that $5.10 initial fee. You're only paying an additional mileage cost at that point. So we just need to really figure out how much does 3 miles cost, because then you're going to take that and add it to the $5.10. Question 6. Pick any 2 points on the graph that you draw and subtract the second coordinate. Then divide the result by the difference of the first coordinate. Each person in your group should pick a different pair of points. Okay, so I specifically chose these 2 points. Those are the same points that we just did in question number 5. 5 miles cost $18.10. 2 miles cost $10.30. Notice I'm subtracting the y's, 1810 minus 1030, and I'm subtracting the x's, 5 minus 2. Then you get this, okay, I did top, subtract top, 780, subtract bottom, you get 3. Divide those 2 and you get 260. And this represents the cost per mile of the cab ride. And we keep getting $2.60, so hopefully that number is sounding very important right now. Okay, and if you look right here, this is super important right here. Okay, that is the slope formula. So that's how we find the slope of the line, and that represents how steep the line is. Basically, what this is saying is that this one is always going to increase at a rate of $2.60 per 1 mile. Okay, so that's the slope. Look down here. I starred this. Memorize this formula. You need to know this. This formula will not be given to you on tests or quizzes. You need to know that formula. Okay, it's a super important formula. You subtract the y's, divided by subtract the x. And then I also did an extra example here on the did you get it? 30 minus 10 is 20. 8 minus 3 is 5. Divide the two answers, you get 4. It means the slope is 4. Also notice that we use the variable m to represent slope. So anytime you see me write the letter m, I'm referring to slope. Okay, moving on. So this page is going to do a lot more practice using that slope formula. So basically on this one, it gave you a picture. It asked you to put just numbers. So I put the 0.1, 770 would be here. This 5, 1810 would go here, and label the coordinates, which is what I just did. How much more distance was added to the ride going from 1, 770 to 5, 1810? Label the value on the triangle. So I took the 5 minus 1, those are my two x values, which is 4, and I put 4 miles right here going on this line. And for question 9, I subtracted my two y values, which gave me $10.40, and I wrote it right over here. Find the slope of the line using your answers from 8 and 9. Take your two answers, divide them, make sure y goes on top. And I just want you to note that this is the same answer that we got in question number 4 and 6, $2.60. That's the slope of the line. Okay? How much would 4 miles add to the cost of a taxi ride? Well, 4 miles cost $10.40, right? So would it matter if you changed was from 1 to 5 miles or if it was 20 to 24 miles? No, it doesn't matter because you're only paying $2.60 per mile. So if you do $2.60, multiply it by 4, that's how much money you're paying for those 4 miles. And then you just have to factor in that initial fee. So it doesn't matter what length of the segment you're going, 4 miles will always cost $10.40. Right here, it says the thing that a line, in fact, that the slope never changes. We know that the slope of a line describes the rate at which the y-coordinate changes compared to the x-coordinate. How can you decide if the relationship between two quantities might be modeled well by a straight line? So if you calculate the slope from 2 or 3 points and you always get the exact same slope, then that means that it is going to be linear. If you calculated the slope between two different sets of points and the slope was different, then it would not be a linear function. Okay, question 13. Estimate the distance of a $16 cab ride. You can use either table or the graph, but make sure you explain it. So what I did, if you go up to the graph and you're looking for a $16 cab ride, so I'm going to go back up to my graph on the previous page, and I want $16. So here's $16. I'm going to go all the way across the line, and I'm going to look. It is just about $4 miles. It's just over 4 miles is where it gets to the 16. Okay, so that's how we're going to answer that question. Okay, so I said the point on the graph at a height of 16 is just a little bit to the right of x equals 4 on the horizontal axis. That means you can go a little bit more than 4 miles. All right, next question. We have, this is representing a car's value over time. So if you look at time 0, it was worth $15,000. After 1 year, it was worth $13,000. After 2, it was worth $11,000, and so on. Hopefully you guys can see that the value of the car is depreciating at a constant rate of $2,000, meaning that if I subtracted $2,000 each time, it would take me to the next number. And you can see that these points over here correlate with the numbers that are on the table. These markings we'll go over in a little bit there for future questions. So it says find the y-intercept. Where does the graph cross the y-axis? It's always going to be when the is at a time of 0 or x is 0. So 0 crosses at 15,000. We can find that right here from my table right there. That is the initial value of the car at the time that you bought it. Find the slope. I chose to do the first two numbers, 15,000 minus 13,000 divided by 1 minus 0. It does not matter what numbers you choose. You could have chosen any of these 2 points. You should have gotten the same answer. And just note that when I did 2,000 divided by -1, I got -2,000. And that means that the car is decreasing in value by $2,000. The negative sign means that the value is going down, not up. Estimate the value of the car after 42 months. Well, first thing, this is in months, right? The time is in years. So in order to do this question, we need to convert 42 months into years. So there's 12 months in a year. 42 divided by 12, give me 3.5. And if you go up to the graph at 3.5, you come right about here, which is about $8,000. So you can see that's why I did the circle there. The next question, estimate the number of years it took for the car to reach $6,000. I went up to my graph. I said, well, 6,000 is right in between 4 and 8. I went across and I said, well, it's just about 5 under, somewhere between 4 and 5, probably a little bit closer to 5, which is why I said about 4.5 years. You could have said 4 3/4 years, something like that. It does not have to be exact, but just make sure it's somewhere in between 4 and 5. All right. Moving along, giving a description of how to find the slope of a line and why it represents rate of change. So to find the slope, you're going to pick any 2 points on the graph. You're going to subtract the y coordinates. Then you're going to subtract the x coordinates. You're going to divide y by x. This is important. A lot of the big common mistake is to do x divided by y. Make sure you do y divided by x. And then you're comparing the change in y to the change in x, which is what the definition of rate of change is. What is a y-intercept and an x-intercept? A y-intercept is the point where the graph hits the y-axis. It's always the starting point of the graph, and x will always be 0. An x-intercept is the point where the graph hits the x-axis, and y will always equal 0. All right, so that's the end of 3.1. Tonight for homework, you need to make sure that you do 3.1 applications. You need to do question numbers 1 through 11. So you're doing all of the applications and all of the prep skills. And there are a couple reflection questions as noted in the syllabus. You are going to upload all of that into Blackboard in the assignments category. And if you're having any trouble, please let me know. This is a learning process. And please let me know if you have any questions or if you need to meet. And we'll be using meeting online at specific times. Make sure you check Blackboard for specific information on that. You guys have a good night. Bye.